Circle geometry strategies. So where are we now with the circle geometry? At this stage we've had 9 videos. They've covered a number of theorems. We're yet to do the riders, but they've introduced the theorems, lots of practice with the theorems, and now we're about to get into the geometric riders, the rigorous proofs. So we need a good thought process, a good thought strategy. And in fact, the most important overriding factor, know your theorems. Let's go through the theorems briefly. Here we are. Chord theorem. Line from the center of the circle to the midpoint of the chord is perpendicular to the chord. Reference chord theorem. Next one, the converse of chord theorem. The perpendicular from the center to the chord bisects the chord. That's converse chord theorem, but if you refer to it as chord theorem, that's fine. Then we have the angle at center. Angle at center subtended by that arc is equal to double the angle subtended by the arc anywhere on the remaining part of the circumference. Arc, angle, double on the remaining part of the circumference. Arc, angle, double the angle on the remaining part of the circumference. Arc, angle, and double the angle on the remaining part of the circumference. Notice that all the curves go in the same direction. You cannot have some up and some down, then you know you have something wrong. Reference, angle at center. Coming off that, a couple of other theorems. Here's one. There's the angle at the center, a straight angle, 180 degrees. And the angle subtended on the remaining part of the circumference there, well, this is double that, so that must be 90. And this is the angle in a semicircle. Angle in semicircle. Here we have what looks like the bow tie or the butterfly. And there's the arc subtending two angles on the remaining part of the circumference. They're equal to one another because they're both half the angle at the center. Half the same angle. Same here. So there we are, angle in semicircle, angles in same segment or angles subtended by the same chord. And then a corollary to that, if we go back to that, there this arc subtends that angle and that angle, in other words this chord here. Now if we go on, these are equal chords, which means these are equal arcs, and they are subtending angles on the remaining part of their circumferences. Well, hopefully it's logical to see that they must be equal to one another because these arcs are exactly the same. So we can call that angles subtended by equal chords or angles in equal segments. Then we have the cyclic quadrilateral. Cycle, bicycle meaning circle, quadrilateral in a circle. Opposite angles, supplementary. Opposite angles, supplementary, adding up to 180. Here we have produced one side of the cyclic quad and we get an exterior angle, and the exterior angle equals the interior opposite angle. Consider this angle plus this angle, 180. This angle plus this angle, 180. Therefore these two must be equal. Exterior angle, cyclic quad. So opposite angle cyclic quad, exterior angle cyclic quad. Now we get to converses. A converse, if the theorem says if this then that, the converse says if that then this. Not always necessarily true, but these are true. We have a circle, angles in the same segment. So now, circle, angles in the same segment, therefore equal. These angles are sort of like in the same segment. They're subtended by the same arc on the same side of it. So therefore, these two equal means that those 4 points lie in a circle. Converse, angles in same segment. And here we are, this quadrilateral, those add up to 180, meaning that those do 2 because these total 360. So if those two add up to 180, it must be a cyclic quad. Converse, opposite angle cyclic quad. And with the exterior angle, Quadrilateral exterior angle, this angle equals interior opposite angle, means it must be a cyclic quad. Converse exterior angle, cyclic quad. Let's get on to the tangents. There's a tangent touching the circle. There's the point of contact, and we draw a radius to that point of contact. Now if we draw a line anywhere else to this tangent, it'll be further. So this is the shortest distance to the tangent, is to the point of contact. And hopefully you know that the line from a point, the shortest line from a point to a line, another line, is a right angle. Or in other words, the shortest distance from a point to a line is a perpendicular distance. Therefore, the radius must be perpendicular to the tangent, and we call it radius tangent, rad tan. Now, follow on from this, we have a tangent, a chord. There's an angle subtended by the chord, and it's on the opposite side to where this angle is between the tangent and the chord. So what this theorem says is that if a tangent is drawn to a circle and a chord is drawn from the point of contact, then the angle between the radius between the chord and tangent is equal to the angle subtended by the chord in the alternate segment on the other side. Now it actually says angles, so if a tangent is drawn to a circle and a chord is drawn from the point of contact, then the angles between the tangent and chord are equal to the angles in the alternate segment, because there are two angles between this tangent and that chord. So this angle is equal to an angle subtended by the chord on this side of this segment. Alternate segment theorem, angle in alternate segment, or tan chord. There is a corollary to tan chord. If we drew any two lines there, this would be equal to it by tan chord, so would that. So these two angles are equal, making these two lines equal by lines opposite equal angles. Sides opposite equal angles in a triangle. We don't need these angles drawn in, nor that line there, but these are still equal. They are tangents from a common point. Tans from a common point. There's the reference. And then finally, there's our tan chord, alternate segment theorem. Tangent, chord, angle is equal to the angle on the opposite side. So here now we have no circle, but we have this angle equal to the angle on the opposite side. That makes this a tangent to the circle through those 3 points. And the reference is converse tan chord, converse alternate segment theorem, or converse angle in the alternate segment. Another necessary strategy, of course, is geometry is not like a dog. It's not going to come to you. You're going to have to think about it. You can't sit there looking at a proof and think you'll see it. You need to ask questions. So let's look at strategies so far. Know the theorems. Don't wait for the geometry to come to you. Now I've added a third. Start with what you're finding or proving. We've looked at that before in an earlier video. A reminder from then. Here in the kiddies book we have 3 pirates, very scary, who are standing at pathways, one leading to some rocks, other to a broken bottle, and one to the pirate treasure. And the question says, which one of those pirates is going to find the treasure? Now, any self-respecting kid is not going to go from there and follow all these paths. I know I never did that as a kid. I went to the treasure and I went back to see. Well, here we are. Aha. Pirate B. So go to the end result and come back. And that's what we mean in geometry. It's better to start at the end, at the angle you're trying to find or prove, and work back. Let's look at an example. Find x and y, giving reasons. Now in this case I could start saying, oh well, that's equal to 41 because of tan chord, that's equal to 41 because of tan chord, etc., etc. But while it may work, it's usually more time consuming, and when you get to rigorous proofs, that sort of thinking falls down. So rather what we do is we say, well, what is x equal to? That's the question. What is x equal to? Well, there we have parallel lines, alternate angles. So x is equal to that. Now we say, what is that equal to? Well, there are by tan chord. So we've got it. So in order to find x, all I do is I go from there back the other way now. I say A1 is 41 degrees by tan chord. Therefore, x is 41 degrees by alternate angles, parallel lines. There's another way to find x. There's often more than one way. Have a look here now. There's the bow tie. We have the angles in the same segment. So we have x equal to S1. And what's S1 equal to? Aha, P1. What P1 equal to? The 41 degrees. So now we go the other way. We say P1 equals reason, S1 equals reason, x equals. Let's have a look at y. What's y? What is y equal to? So there's y. Y is actually an exterior angle. Do you notice that? It's exterior to this quadrilateral there, the cyclic quadrilateral. It's also exterior to this triangle here. Look, producer side of this triangle, and there's the angle. So either we could talk about y being equal to that angle by exterior angle cyclic quad, or we could talk about y being equal to that angle plus that angle by exterior angle triangle. There, exterior angle cyclic quad. Y is equal to the whole of angle B. And B, if we know B1, we know the whole angle B because we know x. So we say, oh, B1 equals 38 degrees. There we are, angles in the same segment. Y is equal to PBS, the whole angle, which is therefore the x 41 plus that 38. Or we could go about it another way, and that is the exterior angle triangle. Y is equal to that plus that, so all I need to know is that. Well, that there is equal to that one by angles in the same segment. So therefore y is 79 degrees. Now, if proving two angles equal, take just one of them and say, well, what is it equal to? So we're no longer finding an angle, but we're proving two angles equal. So we take one. Here's an example. These are straight lines. Prove that L1 equals L3. So I'm going to start at L1. And I'm going to say, well, what is L1 equal to? Well, there's the bow tie. L1 is equal to P1. What does P1 equal to? What about there? Vertically opposite. What is P2 equal to? There we are, the L3. So now we can prove it. L1 equals P1, angles in the same segment. P1 equals P2, vertically opposite angles. P2 equals P3. Notice I'm going L1 to P1 and from P1 to P2 and from P2 to L3. So we've now shown that L1 equals L3. And I started with just the one and said, what is it equal to? Or what is it combined with? Which can happen. So here we are. This here now, right, center of the circle, BD perpendicular to AC, there we are, that there. We have to prove that AC bisects BAD. In other words, A1 equals A2. So we're going to start by saying, well, what is A2 equal to? B1. So we need B1 equal to A1. But in fact, if you said what is B1 equal to after that, what is A1 equal to, there's nothing they're equal to. Now, what is A1 equal to? Dead end. Nothing. So then I'm going to say, what does A1 combine with? Can I see anything A1 combines with? Well, A1 combines with those two angles to get 180. Or A1 combines with that angle and that angle to get 180. And I like that because this is a diameter, so I know this angle. That's 90, which means A1 combines with C to get 90. B1 also combines with C to get 90. Now, if you combine either A1 or B1 to give C, that means A1 is equal to B1. So here's the proof. ABC equals 90 degrees. Therefore, A1 equals 90 minus C, angle sum triangle. B1 equals 90 degrees minus C, angle sum triangle, which means it's equal to A1. So we've got B1 equals A1. But, it's like an argument, but B1 equals A2, angles in the same segment. Therefore, A1 equals A2. Proven. If proving something about lines or shapes, ask what if it is so? What if these two lines are equal? Well, maybe it makes an isosceles triangle. What if we're asked to prove a parallelogram? We say, well, what if it was a parallelogram? Well, here's an example. Prove that AB is parallel to PQ. So my question is, what if AB is parallel to PQ? Well, A would equal Q because they're alternate angles. So therefore, I'm going to try to prove that A equals Q. So I'm going to take 1. What is A equal to? Well, have a look. There's the isosceles triangle. So A1 equals A equals B. Angles opposite equal sides or isosceles triangle. Now, is B equal to Q? Hopefully you can see the bow tie there. B equals Q, angles in the same segment. Therefore, A equals Q. Therefore, that angle equals that angle. Now have a look. We've just formed the Z shape. So therefore, AB is parallel to PQ because the alternate angles are equal. Now that we've completed something about strategies, the videos after this will start doing riders and rigorous proofs. And we'll use these thought processes and strategies throughout that process.